everyone. My name is Malvika Gupta, and today we are going to discuss one more sorting algorithm called merge sort. I have already recorded a prerequisite for a merge sort, which is the merging of two sorted arrays. We'll proceed. Why do we require that uh, merging of two sorted arrays as we proceed in this particular video? So let's first begin with the introduction of merge sort. The contents which I'm going to cover is the introduction of merge sort, the pseudocode, example, and time complexity. And I will be running a code which is pre-written for you in this video so that it will help you out to see that how merge sort is helping you in sorting the unsorted or randomly arranged elements. So before starting ahead, let's first discuss the concepts of merge sort, how it is going to help. Okay. As you see, the name suggests merge. It means that we will be providing a set of elements which we are going to gradually divide in the powers of 2. Okay, so we will be dividing it in the powers of 2. That sometimes it will be like in the pairs of 2, then 4, then 8, then 16. So it will be like 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, and 2 raised to the power 4. So once you have divided your entire array into one, suppose I have separated these elements, like suppose I have these elements, which is given to me 3, 9, 10, 15. Suppose these are the elements. So I know the sorted array will be like 3, 9, 10, 15, 38, and 47. This is my expected array. This is my desired output. Now what happens is that when we keep on doing it on recursive manner, then we will be having 38 is separated, then 47 is separated, then 3 is separated, 9 is separated, 10 will be separated, and 15. So this is not the way to do it. What we are going to do, we will be dividing our entire array into pairs like this. So this is one pair, this is another pair, this is another pair. So I will be having like 38 and 47 one pair, 3 and 9 another pair, and 10 and 15 another. If suppose it might be happening that suppose these two elements are not arranged in an order. So what will happen? It will first get arranged into an order. Let's say, let's take an example for this. If suppose I'm having certain elements, which is 38, 23, 4, 3, 9, and suppose it is 7. Okay. Now you can see if I divide it into the pair. So it will be in two powers of 2. So it will be like 38 and 23, 4 and 3, and 9 and 7. What will happen then? You can see that this is an array, this is one array, this is another array, and this is another array. This is just I am asking you to assume it. Okay. So what will happen in merge sort? It will keep on dividing into the powers of 2, and we will have to sort them over here. So now you see the 38 and 23 will be sorted like 23 and 38. This is one array. Okay. Then 3 and 4, another array. This will become like 7 and 9, another array. Now, what we are expecting that we have to combine these two because we have to do it in the 2 raised to the power 2 powers of 2. So what will happen if you keep on combining them? So here we will be doing merging of two sorted arrays. Okay. Now you can see that how to do the merging of two sorted arrays. These are two arrays 0, 1, 0, 1. If I consider this as A and this as B. So now you can see that we have two arrays which is already sorted, but now we have to combine them, merge them together by making the order perfect, right? So you can see that if I do it, we know that merging of two sorted arrays, we know that until and unless if this is suppose the length of this one is n and length of this one is m. So we can move with, for this array, I am moving for I, and for this array, I am moving for j, let's suppose. And there has to be some third array present with us. So what will happen? This suppose indexing will be like k. So I'm writing that till this is less than n and this is less than m. Whichever will come out first, we will be handling that. So what will happen? If suppose my AI, the element in AI is less than bj, then you know that definitely in my C array, which is my output array, k, which I have already initialized with k equals to 0, I equals to 0, and j equals to 0. So this will be assigned over here, and I will be increasing the value of I and k. right? This is the one pseudo code if this is. But now you see that this condition is false because AI is 23 and BI is 3. A0 is 23 and B0 is 3. So it is not going to be possible. It means we have to go the other side. So what will happen to the other side if you see? Then other side will be like, else I am going like C of K will be having B of J, and we are increasing K plus plus and B plus plus. So now 3 will come over here. Okay. Now if you have taken care of this one, it means that J has to be increased because now this element has been taken care. So we have to move our J to the this position. Now you see again, but your I is not moving because I will only move if this condition gets true. Now you see, if again I'll compare 23 with 4. So I know that this 4 is the lesser one. So again, 4 will be placed over here and then you will come out of this loop. So whatever is left, you just need to put it inside this one. And this we have already discussed in the previous video, which is the kind of a prerequisite for a merge sort. So I want each one of you to please watch that video before moving ahead for the merge sort. Okay. Now you see that this way we have completed our proper and this merging has been done. Now we have these two elements also left in one another array. So this is my one array and this is my another array. So what will happen? Again, I will be doing the same thing. These are the two sorted arrays. Now I have to merge these two sorted arrays so that resultant array will be like this, 23 and 30. Okay. So all these stuff I am going to do when I'm going to explain you through an example. But what I wanted to tell you in this, that merge sort is not going to be applied directly on an array, or we will not be going it like the way we have used in the selection sort, like we will be selecting a particular element and then we'll compare that element from the entire array. Okay. Or we are not going to the like insertion sort where we have considered, okay, this part has been sorted and the rest of the part is the unsorted part. Or else we are also not going through like a bubble sort concept where we have considered the passes and steps. Okay, so merge sort is like that you have to keep on dividing your entire array. So, and then after combining them, we have to combine and we have to go for the sorting, and then we will be combining the sorted arrays to get the resultant output array. So it means merge sort has been an important algorithm and an example of divide and conquer. Okay, so this is one of the example for divide and conquer, which you will be going to study deeply in your upcoming videos. But this merge sort is the concept of divide and conquer. You keep on dividing and then you have to conquer, means that we will be doing the sorting and then at last we will be combining the sorted arrays, right? But now the question arises, because for any sorting algorithm, this is the most important question which we need to answer, is that there are two things which is stable and in place. Because when we consider certain things, we have to be very much clear about our time complexity and space complexity. We have already discussed, because we have now gone through so many videos and we are learning about data structure. So there is a concept called time space trade-off. So we always have to understand that what is time space trade-off, how to do this, what is time complexity, what is the space complexity, why it is important to maintain both of them. Is it possible for us to have the minimum time and minimum space, or is there anything like this that if we increase the time then space will get decreased, or if we decrease the space then what will happen? So all these things, so with this we have to calculate. Till now, whichever the algorithms you have studied, you have seen that the maximum time complexities we have is the order of n square, which is the worst case time complexity. Now let's see whether in this particular video we'll be analyzing whether merge sort will be able to give a time complexity less than this one. But before moving ahead, I will be asking you this question and I'll expect you to answer this question whether this merge sort algorithm will have some space complexity or not. Because bubble sort, insertion sort, and your selection sort is not having any kind of space complexity because they are working in the same array space which is given to it, right? Now you see stable sorting, we know that stable means that if the duplicate elements are present, so definitely we will be doing that the duplicate elements will come in the same order, which is in the way they are given. But if you say in place mean if we are doing certain work in the given space which is already given to us, input space, and no other space is required, then it shows that it is an in-place sorting technique. Otherwise, it is a not in-place sorting technique. So merge sort is a stable sort. Yes, if the duplicate elements are present, then it will sort those elements in the same order which is given to it. And in place, no. As we can see that for merging, we need a new array because we have already done this. The concept of merging of two sorted arrays requires a new array in which we can put our resultant data. So it is not an in-place sorting technique, yes, but yes, it is a stable sorting technique. Please remember this concept. Okay, so this is the way we have to perform this merge sort. I'm going to use the concepts of recursion. Okay, and merge sort is very important, and also you should understand that what is the concept of recursion, how we are going to form this. I will be explaining it to you through a diagrammatic representation, which is kind of a tree-like structure you will be seeing. Okay, so now let's start with the pseudocode of merge sort first of all, then I'll move forward. Okay, so now if you see, if suppose I have to make, suppose a merge sort is there. So this is the pseudocode of a merge sort. Okay, where we will be having an array A. Okay, it is of some size. There will be a left element and there will be a right. Okay, these are the three things which I'm going to pass into it. Okay, so first point in merge sort, if I say, then I am saying that this sorting algorithm will keep on running until and unless you are not going to have L greater than R. Once L becomes greater than R, then you'll have to stop. Okay, so it shows that if L becomes greater than R, then you'll have to stop. So I am writing it over here. Okay, so okay, so now let's see that if suppose what I have told you, that if this will work until your left is less than right, because we have two endpoints for this. So suppose I am writing left is less than right. Then what we are going to do, to go for merge sort, we have to calculate a midpoint, mid index. And please remember that these are two indices I am talking about. I'm not talking about the values. These are two indices, left and right indices. This is okay. So then if this condition is true, then what I am going to do, L plus R divided by 2, and this whole will be in your floor value. So whatever is the minimum value, suppose it is 2.5, then we are going to take 2. And then once you have calculated this, then we'll be calling merge sort. That depends on you. That one will be calling for the left side, and then we will be calling for the right side. Okay. So in this, I am including this mid index. This will be my left and right. Again, for the right part, I am calculating it with A mid plus 1, because I have to start from the next to mid until right part. And then at last, when these two will get run, and this running of these two functions will depend on this one. Okay, this is a recursive call. Okay, recursion is happening over here. So I am writing it for the merge. So merging, I need A, L, your midpoint, and your right. Everything we have to give. Okay, because every time we have to provide certain values, because we'll keep on dividing all these things. Okay, fine. Now this is my entire merge. Okay, so now let me first explain it to you that how merge sort is going to work for these particular values, for this particular function. Okay, always remember that your this function will run until this condition is true. Once this condition becomes false, you will be running for this one. Again, when both of these two will run for both the sides, I mean right subtree and your left part is run completely, then only you will be moving to the merging part. Okay, so now let's take an example and then I'll explain it to you that how it is running. If suppose this is my tree, okay, this is my array. I'm writing it over here: 38, 27, 43, 3, 9, 82, and there is 10. Okay, 0, 1, 2, 3, 4, 5, and 6. Okay, so if you see the left, L equals to 0 because this is the leftmost index and your R equals to 6. Now you have to find mid. So I'm writing it as M. So M will become 0 plus 6, which means 0 plus 6 divided by 2, which will become 3. It means this is your mid index. Okay, now what has happened, if you see from here, then because this condition is true, 0 is less than 6 condition is true, that is why I have calculated this mid index. Now I am putting, because first of all we have to run this one, and this will keep on running until and unless this condition is true. Okay, so I'll keep on running this one. Now see, so now this will include, this part will include your mid value. Okay, so I'm making it like this, step by step you can understand. 38, then it is 27, then it is 43, and then it is 3. 0, 1, 2, and 3. It will be included. I'm not taking this part only, this part right now. I will consider this part once I have finished with this one. Okay, now your left equals to 0 and your right equals to 3. So this is your, if you see, this is your first part in the division you are doing. So divide and conquer. First, right now we are doing the division part, divide part of the divide and conquer algorithm. Okay, now let's see. If you calculate mid, 0 plus 3 is 3. 3 divided by 2 is 1.5. So if it's like a floor function, then definitely we are going to choose 1. Okay, so if you want, and now you can see also this condition is true. 0 is less than 3. So we can directly calculate 0 plus 3 divided by 2 is equal to 1 point. So 1.5 will not come. It will be like floor value we are taking. So it will be 1 value. Okay. So now your mid will be here. Again, I am breaking it down. I am bringing it like this, 38, 27. So this is 0 and this is 1. Your L equals to 0 and your R equals to 1. Okay. 0 is still less than 1. So it means you can again, condition is satisfied, it is true. So we can calculate mid. So mid will be calculated like 0 plus 1 is 1. 1 divided by 2 is 0.5. So definitely the value, so expectedly the answer will be 0. So this is your mid value. Now you see, this is my mid. So 38 will come over here. This is 0th index. Now you see, your L equals to 0 and your R is also 0. So 0 is less than 0 means condition is false. This condition is false. It means you have completed the execution of this part for this particular index, for this. So we'll move back, okay, because the rest of the part, second. Now the right side will come. Now, what's your right side? Right side is saying that your array, your mid plus 1 and your right index. Now, mid plus 1 is your 1. So, this is like 27 will come here. Okay. And this is 1. Now, you see this will become L equals to 1 and your R equals to 1. Again, 1 is less than 1. Condition is false. So, if it is false, it means that I have executed these 2 points for a particular 38, 27. Now this is going to be my third one. This is the merging of two sorted arrays. Now you see the two sorted arrays, 38 single element. So we are expecting it to be sorted. It is obviously it is a sorting array. And this is 27. It is already sorted. So what we can do, we can combine it like this. 38 and 27. It is 0 and 1. The process is completed. Again, we will move forward. So we have come from here and then we have to go here. This is entire process is complete. So the pointer will go back to the, we'll backtrack and backtrack because left side is completed. Left function is completed for this one. Now the right side. So you know that right side says that you will be having mid plus 1. It means 43 and 3. So 2 and 3. So here L is 2 and R is 3. Again, if you see 2 is less than 3, condition is true. If it is true, then you can calculate mid. 2 by 3. 2 plus 3 is 5. 5 by 2 is 2.5 and the floor value will become 2. So it will be like breaking. It will be 43. Okay. And 43 is 2. So your L equal to 2 and R equals to 2. Condition is again false. So if it is false, then it means that we have completed our left part. We have to go for the right side. Okay. Control will go back here. Right side means this part. Now you see this is 3 value. Index is also 3. L equals to 3 and your R equals to 3. 3 is less than 3. Condition is false. It means we have completed the left and right part for both of this. And now we'll have to perform the merging of two unsorted arrays. two sorted arrays, which is 3 and 43. So it is done 2 and 3. Okay. Now, if you can see that for this particular portion, we have completed the right part and we have completed the left part. So what is, oh, sorry, left part and right part. So what is left here? We have done with this one. We have done with this one. We have left with this one. Merging of two sorted arrays. So these are the two sorted arrays. So I am writing it over here. So if you see that it will come like this one. So merging, we know that 38 is less than 3. No. So 3 will come over here. Your pointer will go to third position, which is 43. 43 is less than 38. False. So it will come like this, 38. Right. So we have to check it like this. Sorry. We have sorted it. Oh, wait. I have not converted it over here. I'm really sorry for that. Very sorry. 27, right. So 27 will come over here. Now we will go over here. Then it will move till here. 38 is less than 43. Again, the condition is true. And your 43 will come at last. So we have done this part. Now the control, because we have completed the entire part for this one. Now we'll go ahead. Now this will be executed in the same fashion over here. Okay. So mid plus 1, 9, 82, and then 10, which is 4, 5, and 6. So your L is 4, your right is 6. Now what is mid? 4 plus 6 is 10. 10 divided by 2 is 5. So it will be 5. So it means that I am including it over here. So it will be like 9 and 82, which is 4 and 5. And 6 will go to this side. Okay. Wait a minute. I'll do it again. I'll take it when it is required, right? Not now. Okay. Now, if you see again, so L is 4 and your R is 5. So what will be the mid value? 4 plus 5 is 9. 9 divided by 2 is 4.5, which will become 4. So it will be like, here it will be 4 and your L equals to 4 and your R equals to 4. Again, the condition is false. So if it is false, we are going back and then we'll be taking care of this 82. Now 82 is fifth index. Your L is 5. Your R is 5. 5 is less than 5. Condition is again false. We are going up. So both of these things happen. So we are merging the two sorted arrays, which will become 9 and 82. The entire thing is done for this one. So we are moving ahead. We will go up and we will see to the right side. So right side is 10. Here it is 6th index. So your L is 6. Your R is 6. 6 is less than 6. It is false. So if it is false, it means that you have completed the right part also. Only what is left is your merging. So now I am going to merge for these two parts, which will become gradually 9, 10, and 82. These are the merging of two sorted arrays. This is array 1 and this is array 2. Now you see for this, the left is completed for this bigger one and the right is completed. Right is also completed. So we have taken our control back over here. Now what the third part is left? The third part is left. The combination of the two sorted arrays, which we have taken here. So I'm writing it over here. The space is not present. So 3, 27, 38, 43. So this is my array, which has come 3, 27. I think it is 38 and 43. Okay. 0, 1, 2, 3. And the other one is, if you see 9, 10, 8. Okay. So this is my array. Okay. Now you see if I combine this one, now I can tell you that how we are doing it. So we know that if suppose I am just explaining you how we are combining the two sorted arrays, merging. Okay. So I'm taking this as an array A. This is an array B. The indexing is for this one is J. For this one is I. It's for this one is J. Okay. Let's suppose the indexing will be 0, 1, 2. This is for virtual. Okay. Please remember this one. Okay. Now we'll be starting with this one. This is my C array and this is the K indexing. And all these indices are started from 0. Okay. Now the condition I'm applying, the length of this one is 4. This array, it is 4. And for this array, it is 3. Okay. So I'm writing while I is less than, this indexing is less than your N and J is less than M. So what we are going to do, we are just going to condition, we are going to check if my AI is less than BJ. Okay. If this value is less than this value, because you have to compare with the first indices only. Okay. So what I am going to do, I am just going to put CK equals to A of I. Okay. I plus plus, and then it will be K plus plus. Okay. This is one. If suppose else, now what I'm going to do, it's else. If else part, it means that it is going the other side. So what I am going to do, CK equals to B of J, K plus plus, and J plus plus, anything you can take. Okay. And this is the end of my loop. Once this is entirely is done, but if you see from here, might be a possibility that your one value will be left because your array is not of the fixed size. And maybe some array has gone up, has been done completely, but one of the array is left. Now let's see what we can do further. Now if you see, you can combine it, right? So I is 0, I is at 0th position, and your J is also at 0th position. I am writing it over here. I equals to 0 and J equals to 0 and K equals to 0. Now what has happened? 0 is less than 4, condition is true, and your 0 is less than 3, condition is again true. And K is at 0. It is given to us. Okay. So 3 is less than 9. This condition I am checking. A0 is 3 and B0 is 9. 3 is less than 9. Yes. Condition is true. So you will put 3 over here. And what will happen? Your I earlier was here, but now I will go here. And K will also get increased, and your one value will be here. Index. Okay. Now J is at the same position. Yeah, I'm not going to change the value of J. J will be at the same position. Now see, 27 is less than 9. No, the condition is false. So if it is false, then what I'm going to do, I'm going to run this else part. So your 9 will come here. Your J will become now 1. I will remain at 1, but K will become 2. Okay. Now see, again I'm going to compare. 27 is less than 10. Condition is again false, because 27 is not less than 10. It means this part is going to run. So your I will remain at the same position, but your J will go to the 2 position. So you will be writing over here 10, and your K will become 3, right? So K is 3. Now again you are going to compare. 27 is less than 82. Yes, condition is true. So if it is true, then you are writing 27 over here, and your I will go over here. It means that the value of I will change to 2. J will remain at its position, and K will be changed to 4. Again, if you see 38 is less than 82, yes, the condition is true. So 38 you will be writing, and your I will go to 3rd position. Your K will become 5. Your I will become 3. J will remain at the same position. Now, 43 is less than 82. Yes, it is true. So 43 you are going to write. But now if you see, I will become 4. Okay, I is 4. K is 6. Okay, but now what happens is, when this value has come, 4 is less than 4. We have to come out of this loop because AND operator has been applied over here. So 4 is less than 4. Condition is false. If it is false, then now, but this 82 has been left. So what we are going to do, we are just going to perform one thing, and that says that if suppose my I is less than M, I is less than N, if suppose I'm taking. So I'm just directly putting the CK equals to your A of I plus plus, and K plus plus. Okay. And if not, then I'm also going to do the same thing for the J. That CK equals to BJ, and J plus plus, and K plus plus. Okay. Now see if it happens. So you can see that the J value, I is less than N, 4 is 4, 4 is less than 4, condition is 4. So I'm not going to go into this. But I can go here. 3 is less than, because here the value is 2 is less than 3, condition is still true. So I can directly put this value over here, 82. Now my J will become 3, K will become 7. So there is no point. If you check, 3 is less than 3, condition is false. So it will come out, and you can find out that at the end of the merging, we have got the sorted array. This is your conquer part. So you have done three things over here. With the help of these two, you have made the division. And with this one, you have combined by sort. Okay, so this is the concept of divide and conquer. This is how merge sort works. I hope this is clear to everybody till here that what we have done in this example. You can try at your own once you are done with the you do with the example. So before going ahead, let me tell you first. Let me show you the code which I have written already to tell you that how we can run this particular code. Okay, now let's see. So this is my code which I have written. I have called from here I have started main. I have taken an array of 10 elements which I have fixed already. Initial values which I have already told you that I equals to 0 and j is equal to 0. Number of elements an array has been passed and L equals to 0. This L is my left, R is my right. I have already told you. Okay. So function which I have created is my merge sort function. An array has been passed. The first index and the last index has been passed. Okay. So now let's see how this merge sort function is working. This is working in the same fashion as I have taken. So this is directly has been written. So I have taken only a new index value, which is mid. So mid is equal to L plus R. By default, it will only calculate the floor function. So you are not supposed to put some functions like floor or ceil. It will directly give you the value of floor function only. Okay, because and by default, it is like integer divided by integer is equal to the integer value. Okay, so this was the first recursive function, AL mid, merge sort, A mid plus 1 R, and then this is for the merge. Okay, so it will keep on running. Now let me tell you that how we have divided the two sorted algorithms so that we can merge them. Now, if you see from here that this is the part, because first of all, the most important part in a merge sort algorithm is this, that how you are going to create two arrays, because here we have to create the left array and the right array. So how I'm going to create it? Okay, so because I have got something which is mid. Okay, so I have created an array which will go, the size of an array is n and the other one is m. So mid minus 1 plus mid minus L plus 1 is my n size, the length of my first array, the left array. Okay, and m will be my right array. So r minus mid will be my right array. Right, now these are the lengths of two arrays. So this is my left array and this is my right array. So whatever will come, it will go to left and right. Now see, all the elements 0 to n. Okay, I'm running it for 0 to n. Will go to the left array, and this is al plus I. It will keep on running like this, and then 0 to m will go to from mid plus 1 plus j. Okay, so as long as your, because j element will be like now you should understand this one, why I am taking this part, this thing, because your j value is not, importantly, it is not going to start from the zero. This it will be starting from 4 5 6 index, like we have seen in our example also. If you see from here, if I'll take you to this part, now you see that when we were doing this question, so you see 0 1 2 3 is there, but 4 5 6 it is started. So you just have to copy one index, we have copied till here, and the other right array we have copied from 4. That's why I have taken over here. Now you see this part. Okay, now from here we will be starting the concept of merging of two sorted arrays, because already the two arrays has been created. So I equals to 0 and j equals to 0 and then k equals to n. So by default you can write it as k equals to 0. That depends on you. Okay, so this is the thing which we are going, I have already explained it to you, that this will happen if else part, whichever will be the bigger one we will be taking. There I have taken C as an output array. Here I am taking A as an output array, if you see. Okay, so this is how we are going to run it. Okay, all right. So, and now you can see that if this condition is true, then you'll be keeping the left value to the output array, and otherwise you'll be keeping the right. So either you can go for it k plus plus in every time, or otherwise you can put it after if or else statement. Okay, fine. So this is the part which we have already done, that if one of the array is not been completed, or we are not been able to put all the all the elements into the output array, just because that element was the largest of all. So we can use these two concepts. Either it will go to I is less than n. If your left array is left, then you can go for I is less than n. Otherwise, you can go for j is less than n. Then once you have done it, I'm coming back to the main function, and here I have put the display function, which is going to display your sorted array. Okay, because array is in array we are going to work on the addresses. it is not going to change. So basically, as we know that array is itself a pointer, so you are working everything on the particular address, on the same address. So whatever changes you are going to make, it is going to reflect in every part. So this array we have called, and you can see your array will get updated. Okay, your output array. Now see, for merging, you have occupied another array. So I've told you earlier also that yes, if my number of elements are n number of elements, so definitely I'm going to take n number of space for my merging of array, right? So let's run this one. Okay, now see, these are the 7 elements. I'm going to take the same number, same elements which I have taken over here. So that will be easy for you to understand. So 38, 27, 43, and 3. 38, 47, 27, suppose, 3, 9, 10, and 82. Let's see. So now you can see that we have got the output, and this is our sorting of array. All right. So I hope you have understood the coding part of this particular concept. Okay.